Okay, so what does it look like when the system is inconsistent? So let's say I had this system and I did elementary row operations, so I'm skipping all the steps, but I got from here to here. So let's look in to see what this last row means. This is saying 0 times x1 plus 0 times x2 plus 0 times x3 is equal to 5. 0 equal 5. That's really bad. So that's when you know the system is inconsistent, when you get something like that. All right, so let's go through and solve these and describe their solution sets. So if I put this one underneath here, so negative x1 plus 3x2 equaling 3, and if I add these two equations together, I would get x2 is equal to 2. And you know that you can substitute back into any one of them. So I'll get x1 minus 4 is equal to negative 1. x1 is equal to 3. And if, not that you have to do this, but just so you give you a picture of what's going on, let's just say I make x1 the y-axis and x2 this axis. So I would have this, and this right here would be the point 2, and this point here would be the point 3. There's my unique solution. So this is consistent. So I want to make sure you're getting used to the vocabulary. This is consistent with a unique solution. Okay, let's do this one. So negative x1 plus 2x2 equaling 3. If I add these two equations together, I get 0 equaling 2. All right, we know that's not true. If I was to draw these on x, y axes, I would have two lines that look like this. So we can see this is inconsistent. These lines do not intersect at all. All right, so if I put this line under here, and I add these equations together, I get 0 equals 0. Well, that's true. So what this means is that if I was to draw the lines, that I would have two lines right on top of each other. So this is a consistent system with infinitely many solutions. So these are the kind of pictures of the three cases. We're not going to have pictures all that often, so this can be helpful for you to see. So we have two cases of consistent and one case of inconsistent. All right, so before we dig into this one, let's make sure we're looking at what the question is asking. Do these lines have a common point of intersection? So that means we can stop. We don't have to go all the way to the unique solution. So let's first put this into a matrix. So I would encourage you to write in the matrix entries by row. 1, negative 2, 1, 0. Be incredibly neat because you got to keep the columns in order too. So there's no x1 terms. You have to put a 0, a 2, a negative 8, and an 8. Negative 4, a 5, a 9, and a negative 9. Okay, so let's talk about what operation I'm going to do first. I want to get a 0 in this position. So I want to take row 1 and multiply it by 4 and add it to row 3. I want you to write this down because it's a lot of mental math, so you'll want to keep track of what you're doing. So I encourage you to write this first row down again, keeping it neat and organized. You need to keep writing these parentheses for the matrix. This row I'm not doing anything with, so I'm just going to carry it along. So multiply this by 4 and add, that gives me 0. Multiply this by 4, gives me negative 8 and add, so that gives me a negative 3. Multiply by 4, that gives me 4, plus 9 is 13. And 4 times 0 is 0, so that stays at negative 9. All right. So I want to get a 1 in this position, so I'm going to suggest that we take row 2, and multiply it by 1/2. So carrying everything along, I'd really highly suggest you do one operation per row. oops, what happened here? 4, no, I'm sorry, negative 4 and 4, and then 0, negative 3, 13, and negative 9. Okay, so now, oh, that's what happened. All right. Okay, so now I want to get a 0 in this position. So I want to multiply row 2 by a 3 and add it to row 3. So I'm going to carry along row 1 and row 2. So multiply this by 3 and add it. That gives me a 0 here. Multiply by 3, that gives me a negative 12, and add it, so I get a 1 there. And then multiply by 3, and I get 12 minus 9 is 3. Okay, remember, what is the question? Is there a common point of intersection? There is. I can see my triangle of zeros here. I can see, not that you have to write this out, but I can see this is saying x3 is equal to 3, and then 1x2, and negative 4x3 is 4. So yes, there is a common point, a unique solution I can see, so it is consistent. Okay, let's just do one more and we'll finish it off.